Okay, class. So today we're going to be talking about scientific notation and how we can use it to express really large numbers and really small numbers without writing excessive amounts of zero. So we have two numbers here. We see here we have the sun's diameter, which is a really big number, 1,392,000,000 meters in length. And we see with this number, it's much bigger than 1. Then the other number we have is the diameter of your average atom, which is a really small number. It's 3/10 billionths of a meter. So this number is a really small number. It's much lower or smaller than 1. So typically what we're going to do is, for scientific notation, is we're going to express each number as a power of 10. With really large numbers like the sun's diameter, the power of 10's exponent will be positive. With really small numbers like the average diameter of an atom, the power of 10's exponent will be negative. So that's key. So how do you determine these values? The key in both of these is you want to make sure that the decimal goes after the first non-zero digit. So I'm underlining in each measurement that first non-zero digit. So with the sun's diameter, which is bigger than 1, we see that the decimal is actually way down here after all these zeros. So we want to move that decimal all the way to the left till it's behind 1. And we're going to count the number of times that we move it and use that as our exponent for the power of 10. So with that measurement, the sun's diameter, we go over, we go over 1, 2, 3, 4, 5, 6, 7, 8, 9. So the sun's diameter would be 1, put the decimal, 0.392. We're not writing out all those excessive zeros, and we're just going times 10, and we're going to use the number 9, and it's positive because it's a much bigger than 1 number. And we can't forget to write the unit of meter as well. So when we go to our other measurement, we see again, we have the decimal. It's actually already in place for us, and we want to move it behind the number 3. So instead of moving the decimal over to the left, we'll be moving it over to the right because this number is less than 1. But that's okay. The only difference is the exponent now will be negative because this number is smaller than 1. So how do we do that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this number would be 3 times 10, and it's a negative 10. We moved it over 10 to the right, and this number is less than 1. That's why it's negative meters, because you always have to have a unit. So I hope that helps with scientific notation. There's a video following this on some practice to make sure you guys are comfortable. If you have any comments or questions, go ahead and email me directly or leave them in the comment section. Thanks so much for watching.